Hello everyone, welcome to HSG Weekly Training section. Today's topic is HSG Tube Operation Software X9000. We will demonstrate the operation step and explain every button function for you. The whole training process will last around 1 hour. If you have any questions, please type it in the dialog box or talk with our engineer after the training. We may not stop during the training. Okay, please focus on the following content and let's begin. My mouse is over here. This is a software version. This is a toggle screen between the operator and the administrator. This is a password. The third item is the English language switch function. Automatic login. Login screen. Press ESC to exit the screen. This is a service state. And the password for ID. The third is the authorization password. Fourth is the number of the authorization days. There's also a set of machine tools for one time. This is a code that has been authorized. This is where the authorization code is entered. It's usually a 16-word authorization code. Enter the license code on the keyboard on virtual keyboard. Then press OK. Authorization code is a log status and unlocking software. It's a refresh authorization code. Authorization. Authorization means click OK. This is the exit button. The opposite column is a pressure interface. Verification maximum. This is a default pressure. This shows you the current speed. This is a maximum speed and present multiplier. Cutting power display. Percentage of power. Maximum power. Present 1 power. The button 4 columns. Axis of motion. Mechanical coordinates. KV remaining distance. KV is acceleration. Remaining distance is the distance from the limit. How long is the limit of the machine tool? X, Y, and Z are the axis of motion. There's a change of value as the machine moves. The laser bar on the bottom left is a laser and is some simple state information. Shutter, guide, alarm. Laser high voltage or optical brake. Red light alarm. This power recommendation is right on the monitoring software. This is not shown. This model also has power. We set it through the software background. It can be read correctly. Current peak power with the current minimum power. Second is a cutting head. It's easy to see the status of the cutting head. Focus. Air pressure. Air pressure alarm. The temperature alarm also has a protective mirror alarm. This protective mirror alarm needs to see the specific what's cutting head. This is the current focus of the cutting head. Here also type of cutting head corresponding to the power. Set the focal pressure. Manually adjust to a focus with these two plus and minus signs. The figure is also a symbol that returns to 0. The third one is our chalk state. The chalk state has a front card and a back card. The front card is a W axis. The open is an open signal. A is a rear chalk. Open is a signal that is open. Here on the right is a clamping software signal. The fourth is the gas interface. The interface has air, oxygen, and nitrogen. This air pressure, oxygen pressure, and the nitrogen pressure, and it has a corresponding gas pressure input. The light will show. There is an option to switch the current gas to manually vent it. Let's say you choose oxygen, press the blow button, and the corresponding gas will blow out. This is a present pressure to site. A little bit. It shows specific pressures. Now we come to the main screen. Here on the main screen, the reset interface has 3 modes and 2 function items. First is a return to 0 mode. The second is automatic mode. The third is a manual mode. The fourth is a system reset. Software above the alarm can reset the alarm here. The system can be reset to reset the alarm. The fifth is a minimization function like this. A workbench above the main interface. Alt option of current processing. It is imported into the drawings of machine tools. Normally, it has a screen like this. A path of processing is shown. The second option is a processing aid. There's a whole bunch of these laser center functions in there. The first step in the laser turning is the center of the light. The first step is to set our point power. By setting the power to control the laser light out of power. It's usually set around 10 to 20%. The light of the time. Duty cycle. The second step is to put a piece of scotch tape under the nozzle and click the light button. Remove the tape and we will know the point in the circle is in the center. If it is in the center, the light center is adjusted. If not the center, we need to adjust. Repeat step 1 through 5 until the adjustment is complete. The second is a calibration option. The lower the cutting head to a position about 10 millimeters away from the pipe. Perform automatic calibration operation. Load the program and then press the start button. Cutting head or machine tool. A collaborated request is read. A collaborative action will be performed. Collaboration. The feedback value is about 9,000. Generally speaking, it's above 9,000. The sighting head is the height followed by the cutting head, generally set to about 1 millimeters. This is a tracking position signal. Here's a collection alarm. When the cutting head follows down, these lights will change. Collection warning. Touching the nozzle with your hand will also trigger an alarm, and the indicator light will. The third is a pipe search. Automatic search does not have the function at present. Still under development. The recommendation is to use this manual mid-find feature. The chuck needs to return to 0 before performing the manual search. When the chuck returns to the origin, it returns to the center of the y-axis. When the center of the y-axis is set the step value here. Then by setting this y plus and y minus to get the center of the ideal y-axis. Then click or active manual search. And then record, apply. When get an ideal y-axis center. This current center is going to become the center of y-axis that we want. The fourth is a support frame option. Variety of models. This kind of support frame that corresponds. And I'll have 3 support frame. By clicking on the support frame option, our kind of indicator light, it will show. What is the state of the support frame? It is corresponding indicator light is not on or off. That's a signal. The signal and the down signal is not in the place. The support frame. A bracket used to support tubing in a pipe cutter. State of the software resides. A lift from the support frame or drop from the support frame. We're back to where we were when we started. So this tube choice, the option is to have a tube, a steel pipe or a rectangular pipe or something. This kind of can pass that's the height of the pipe, width of the position this, the height of the support frame, but this one has to have a t-axis function. This test tube, this is a tube test. The fourth is a heavy tube mode. Heavy tube mode is when you cut the heavy tube. We are going to turn on this heavy tube mode. There's also a medium tube model. The heavy pipe mode is to reduce the empty speed when we cut the heavy pipe. The empty vacuously will be. Pipe test is the first time we failed since we opened. We first check the size of the pipe to avoid hitting the head. Generally speaking, before cutting, you need to return, you need to run empty and then actually cut. So this tube setup is on or off. Fifth one is a chuck. It's an option. This is open and tight. The second one is a blow. Control function. The blowing word is to see whether the current chuck configuration. The back card is a function of blowing and inhibiting. This term is the chuck state. This is a backcard control function. Then the sixth is a feeding interface. Because this is a simulated interface, the order may be a little different. We, according to the actual type, to set or judge. The first one is a single x limit. This is an x-axis limit of the single. The limit should be adjusted when cutting the large pipe. Through the adjustment to control, avoid collection and chuck or claw. This double X limit is the limit of single row or the tubal. Check by changing the clause. To good quality. The third one is the travel of the x-axis. Determines how far the entire machine moves along the x-axis. The fourth is a safe position. The safe position involves whether the feeder can send the signal from the pipe cutter. That's when the real card moves back to the safety signal switch. That's the x-axis right here. The position of the moving chuck is that the feeding machine sends the tube to the machine tool. The chuck moves forward. The x coordinate value is the position of our moving chuck. This fixed chuck position. If the chuck has been clamped to the feeding machine sense pipe, move forward to the front chuck. The first part of the clamp tube has gone into the front chuck and x-axis coordinate below the cutting head is a fixed chuck position. So this is a feeding process. Clicking on this will show you the specific steps that comes out. In the upper right corner, there is a feeding enable. Open and turn it off, and there will be some hints. The green end is an enable function. Cycle loading. Right after, that's fully automatic process. Auto start. This is a feeding machine. Top 100 tubes that can be circulated, 10 tubes. Automatic processing is a cycle of feeding open after the end of the feeding process. Do not need to cut by pressing, and beginning of the handbox. This should be controlled according to the model whether to start automatic machining. This is based on the model, so this altered clip is. The chuck has an inner clip and an outer sheet. Through the actual situation, to control the situation of the clip. The second clip is to consider there is a clamp deplication in the process of feeding, the process of printing. Whether to enable the secondary clip. Bottom one is the automatic feeding process. This is a residual material function. When you turn on the blanking machine, there will be a corresponding action. Blanking function. It's just a piece of material like a flip plate. And then this is a scaffold. Feedback baffle. There are also some reversal conveyors of that kind. And the ruler. There are the on and off function and button. It's a function that is manually triggered. This is a flip plate. This is a ramp. This is a scrap flap. Tube error detection. Need to open a subroutine to edit. Manual compensation based on the error we detected. It's going to put in a deviation here. The deviation value of manual. The center of the cut piece will be improved. It's good cutting accuracy. Weld compensation. This optional function is not standard. This position that we figure out. Chuck has an automatic flip function. Turn to the weld that distance to start cutting. This weld detection is an optional feature. It actually wants to draw a line on the surface of the pipe weld. In this way, we perform weld inspection on the machine too. When the actual weld is detected, the corresponding value of X and Y will be given. This is an automatic weld inspection, the manual weld inspection. When you turn off the detection function, manually transfer to weld surface. At the 0-degree surface of this weld. This is a step angle. The rotation angle of the chuck. This is a kind of pipe that chews the weld. Tube method, rectangular tube. Fourth is to specify the weld surface or specify which side the weld is on. The zero surface of plate 90 degree. 190 is the same plane as 270, means that a root canal. There are welds. I need to draw a line on the outside. This is a weld. And then the software can recognize the line, judge it as a weld. It will be compensated. Then XY. XY is identified as the weld is subjected. I'm going to shift it to X-axis or Y-axis. This is a ready-to-process interface. An NC program to be prepared for processing. Fourth is a processing record. It's usually where all your processing are. Here's a start time and stop time for processing. This is a name of NC and the size of the pipe. Just adding this and this screen is where we add the NC program. Generate a good NC code into the machine tool. Number of the editors. Number of sightings. Corresponding window will pop up. Set the amount we process. Processing to the lower right corner of the interface will show this location. Delete the current task. Editor. Current imported. NC code, click on this and he will print out a window. I can edit the code inside. Report is the output report. There are reports in the nesting software. Is generally not required. Output equipment processing time, pipe type, and so on. Listen the eraser. Clear the current processing record. So this option is an option. It's pretty much the same choice we just had. It's a function that opens the NC interface. Program editor used to modify the function of the program. Shortcut function. Function for one button under the residential material is to be realized through the automatic function of the residential material. There will be corresponding action only when the next residential material is enabled. Movement of the back chuck moving forward, the front chuck opening and the back chuck opening. Return to the origin of the workpiece is the completion processing. Click back to the origin will return to the origin of the workpiece. Back chuck will go back to the X coordinate before it started cutting. Is it convenient for the second tool? That option is to move. Map comes in with a cut path, and this is the one that moves the cut path. Program. Static NC code. This is centered. Mirror. Zoom in. Arrow key. Processing database. Large outline in small outline. Corner, punch 1, punch 2, punch 3, mark. The first term is a cutting speed. The column is a standard value. Column 2 is a user value. The third column is a unit. The fourth is a description. General processing selection loading parameters are user values. Instead of loading a standard value, open parameters and shift parameters. The second is a lead speed. Speed of cutting leads. The third term is the maximum power of that cut. This is a minimum power. Type of piercing selected. Laser mode is generally continuous mode. Laser frequency is usually 5000 Hz. The duty cycle is selected according to the corresponding parameters or processes. Same is true or gas, depending on the material and parameters. Pressure is adjusted according to the actual cutting effect. Cutting head is generally set at 0.5 to 1 millimeters. Cross-hair sighting, cross-point sighting. Stop air delay and close air delay. Turn on delay out, turn off delay. Showing us is usually on. Otherwise, you might have a problem with just the code. The acceleration factor is always 100%. Corner acceleration is the acceleration when you cut a square or round job. Arc counter accuracy, the acceleration you control when you cut a circle or curve. Tilting is a speed of which the machine responds. The faster the reaction, the higher of the number. The new process parameter. Required process parameters can be selected. Save the current process parameters. Load standard defaults. Load user defaults. We are advised to load the user value. The customer only needs to modify. The standard value is only used as a reference. New process parameters. Save the parameters. Remove parameters. This is a backup. Backup process parameters. Administrator password is required to access to the setting page. There are 3 outlines, small and large. Here's another mark. There are 4 layers to sight. When there are special requirements on the process can be achieved by layering. Marking the layer requires setting the corresponding layer in the nesting software. Get the desired result by marking the craft sightings inside the layer. Menu interface. Axis of motion. Menu function. MDA is not used to modify parameters. Continuous mode of motion axis function. Back to 0 mode. Incremental mode. Continuous mode is used for fast movement of machine tools. By holding down the number, you can move it. Back to 0 mode has a single axis back to 0 function. Incremental mode is similar to stepping. Set the corresponding value and move the corresponding distance. Click the corresponding motion axis. And the coordinate of the corresponding axis move the value side. Menu interface. Open, expansion chuck, manual trigger function. Sense R. The bracket also has a manual trigger function mentioned earlier. Automatic feeding has just been described more than a feeding panel. The feeding panel has a feeding machine IP. The IP of the feeding machine is connected through the network cable. The IP must set correctly. Otherwise, it's not working, or maybe the IP is not set correctly after automatic reading is turned on. The feeding machine reads the tubing and sends it to the equipment. App data will show up. It's usually an auto read. This is a button to start feeding. Automatic blanking is the same as before. Don't see much here. Of these terms are pretty. You now have a higher length option. Length of the head is mainly after the feeder tube. Back chuck, forward chuck feed tube to the front chuck clamp. Distance between cutting head, read line, and pipe head. And the front chuck clamping position can be adjusted through this. The lifting of the material frame is a coordinate. The lifting, you can set it here. Feeding enable, cycle feeding, automatic processing. Front and rear end positioning. It should be selected according to the model. Generally, you look at the location of the pad, either to set it at the front end or the back end. This is a diagnostic screen. The current alarm is shown here. The second option is a historical alarm. Shown on the right is an I/O interface. I/O interface is through all motion access, laser, follow, gas, and other I/O settings. You can observe the state of the machine too through the interface. Version information. Check whether the machine 2 has an interface to connect the internet. Administrator password is required to access the setting page. Password is administrator is HSG laser 2017. Printers. So let's go to the setting screen. Start. Shaft equipment, core components, safety components. Let's start with the shaft equipment. Loading and unloading this is a basic setting. New speed. House evaluate the positive and negative unit, the second negative limit. It depends on the model. You are not advised to modify the parameters. If you want to modify, you need to consult our software engineer or after-sales engineer. The second is the return to zero setting. axis of the motion is shown above. Whether to enable back to zero direction, course return to zero speed, find return to zero speed, back to zero offset, sensing the offset position after the origin, back to zero coordinates. Advanced setup. Do not change any of these settings in advanced setup. This is a basic setup of machine 2. Space shifter velocity, arc modifier, space shifter, driver I and O configuration. Click on this and you will see the address of the driver. Axis of the motion. Site. Corresponding ID. This thing cannot alert it at will. It not respond. Therefore, it is generally not recommended to modify. Again, it's a software parameter settings. Also, some parameter settings of the software corresponding to the I/O address and each shaft port, outlet, and so on. PLC. Software loaded machine 2 action program. All the cutting action will be here. Because what I have here, therefore the PLC cannot be loaded. Air moving speed refers to speed at which the machine is moving without cutting. It is not recommended to change it. Circular arc acceleration is multiplier of the cut arc because it involves the action of the machine 2 coordination, not recommended to modify the parameters in here. We do not recommend to random modification. Path accuracy. It involves the precision of cutting, contour, and cutting arc. Lower gun is height biased. With the prover in the rear, there will be a slight offset above the sip height. Raise the nozzle of the gun when cutting to prevent hitting the knife. Front chuck detection angle. An action or function option that defects whether to return to zero. All of these parameters are equivalent of the platform configuration parameters. It's a platform configuration feature because this is an analog. So I can open this option. Let's go into sum in this parameter. As axis back to zero, focus back to zero bit bus, sum functions. Parameters in the setting screen will be included in this all parameters. This is the XYZ axis of motion. First is the return to zero enable. Can go through this. Enable or disable back to access to control this axis, whether to enable to return to zero function. The second is a return to zero frame because there's a limit of plus or minus. To return to zero direction is controlled by controlling this position and negative limit. Back to zero velocity. The course return zero speed is a speed when the origin switch has not been sensed. Second zero speed is a speed after sensing the origin switch. First, the velocity is a little bit faster. The return to zero offset is a distance back after sensing the limit. Zero coordinates. It senses the origin, and when you go back to the origin, this coordinate will become the coordinate that you set. Or component. The first item is a laser. It's set according to the type of laser currently used in the machine tool. Make sure you choose correctly, or you won't get light. The following is the IP setting. It needs to be set in the network configuration. Only IPG needs to set IP. Recus doesn't need to set IP. Each is controlled through the network. Recus is usually controlled through the serial port. So this is a tab that we follow. Which one corresponds to which one? Usually this is not modifiable. This range of sensing. That's a distance that you can trigger. Usually we set it at 0 to 20. This is a follow-through kind of monitoring. This IP address must be corresponding to the pop-up window. If there's a change, it means the connection is connected, and you can set the parameters inside. But you can just change it randomly. Cutting head. Select the device model. It's all set by default. Focal, collimator, focus. Focal length and the collimation and determined by the lens. The zoom range depends on the type of cutting head. Straight cutting is to allow for a 3D type of cutting head. It has a distinction between oblique and straight cuts. Zero is option relative to the oblique tangent. This is a corresponding proportional valve. Proportional valves are generally used at the oxygen interface. This is a maximum pressure set. Closed loop regulation is a setting with no feedback voltage. Support frame, this option function is to enable the corresponding position of the support. Position of stop. This is to say the chuck goes to this position. If the support frame does not drop, the chuck will stop moving forward. This means that the real chuck is still some distance from the stop distance. The support frame has begun to fall. This distance is a buffer distance. This is a delay time after pressing the chuck to open or clamp. Chuck will have an inflating, so we are going to give it 1. Enough time to release the gas or fill it up. Safety parts involve loading and unloading. Security guard is an interferometer. Front-end blanking inspection. Back-end blanking test and chuck release clamp fast. Feeding machine. The position of the feeding cylinder is 1. The position of the feeding cylinder is 2. Check whether the function of the remaining material is turned on. Function of the discharging residual material needs to see whether the front and rear end discharging material is configured with light sensing switch. There's usually a travel switch or limit switch. If it's a digital chuck, back this chuck release clamp detection is to influence the feeding. The feeding machine reads the check to release of the chuck to feed. Security settings, security protection. Safety protection depends on whether the gratings is installed. You can use this safety guard if you have one. Security door protection. Safety door that pushes up and down at the cutting head. This is an on and this is off. Corresponding protection alarm can be shielded here. This is an interferometer interface. Modification record. This is a record of parameters modification. ESCK to cancel authorization, cancel an existing authorization. CNC is written after modification. We need to write our current CNC. It's through this that you write CNC to get. First press emergency stop and then click write CNC. This is a backup screen. Backup machine parameters. Select the corresponding folder. This is a maintenance interface. We have all the options for maintaining the machine. Lubricating oil. Machine interface will have a display. Information screen cites the maintenance. This is a maintenance record. Here are the statistics and this material. There's an instruction manual for our software. Status, yes, no. Control strip. Processing information, and so on. Simulator of the handheld box. Screen button. End is a beginning. Suspend. The red one is an emergency stop. Blue is a reset alarm. Automatic mode. Manual mode. Back to zero mode. Test pattern. The test mode is empty walk, no light, no air. Function. Laser. Open the shutter. While the red light is on, oxygen, nitrogen, air. For air, we need to see if there's air or nitrogen. Spotlight. Proving operation. Perform collaboration action. These are the chucks. Opening or clamping of the front and rear chuck. These are the corresponding support frame. This needs to see what is a blanking machine. It will have a feed conveyor wheel. This is a rise or fall of the conveyor wheel. The bottom right corner is a dot motion of the axis of motion. Motion button of the corresponding axis. This is a crab flap, cutting slope. This roller conveyor belts. Look at the specific cutting model number. This is a machine state. State of machine 2. Generally, there's an emergency stop of machine 2. Machine ready. Disable. These are the states. This is a display of which modes to switch. It shows the return to zero success screen. So let's start opening. Software or open the NC codes page connection. Top right corner open. Open the corresponding information file. Then we find the NC storage, the location of the NC file above the machine 2. Click on the table. Select the file on the desktop. Open. Name the NC. Becomes the name of the current NC. So this is a type of path. At the mount and so forth. This is an argument that was read. This is a cut path display. And development. So that's up, down, left, right. After importing the graphics, after the device is opened and finished, perform a collaboration action. After the cutting head is moved down, the collaboration is performed. Here we load the program to perform the collaboration. Cutting head is lowered and specific head, and then you start collaborating. The collaboration, the cutting head is lifted. Open the NC code that needs to be cut. Importing the program, you need to perform laser turning. Set the parameters used by the points injection. Glue a piece of clear tape under the nozzle of the cutting head. After staking, click Emission. Take off the tape and look at the burn points on the tape. While in the center of the nozzle import, make sure the laser in the center of the nozzle. The light is not in the center, adjust it until the light is in the center. To the center. You need to set the corresponding cutting parameters. According to the path, thickness to select the corresponding process parameters. Selecting corresponding parameters and adjusting them appropriately. Load user defaults. Switch to automatic mode. We need to test this code before we start cutting. Still work requires opening test mode. The test mode is on. Press start. Stop now, run this NC code. Always pay attention to whether there's a problem with the cutting action. There's no questions, you can pause. Press reset after pausing. After reset, turn off test mode. Leave the cutting head to a safe position. Enable automatic mode. The process start button. The following is a cutting process with loading and unloading. So we go back to 0. Switch to manual mode. Open the process interface. From the center of the light. Attach scotch tape to the nozzle. Laser sound. Verify the born point is in the center of the circle. If it is not in the center, adjust it to the center. Feeding movement. Turn on the feeding enable. Once open, click to start feeding. Normally, the feeding machine will send the PEP to X-axis position. Rear chuck will clip the tube. The back chuck will send the tube to the front chuck. X, the calibration action. Reduce the cutting head to 10 mm from the surface of the PEP. Load the calibration program. Calibration starts after the calibration program is set. The calibration action is completed. The cutting head will rise to the origin. Next, you need to load the NC code that needs to be cut. Test mode needs to be turned on before cutting. Running the program now is correct. Turn on test mode and then auto mode. Press the green button. It is recommended to reduce the speed multiplier. Before doing this, We don't have time to react when there's a mistake. Reduce the speech multiplier before starting processing. The processing processes gradually. Make sure the NC program is okay, then press pause. Then press restart to turn off the test mode. Leave the cutting head manually. Move the tubing back into place. Automatic mode. Start. Now the video is finished. If you have any questions, please leave your message on dialog box. Our engineer will answer you. If you don't have any questions, then it's a time to say goodbye. See you next time. We will send the download link after this meeting. You can download and repeat checking this video again. Thank you for your timing. Thank you for your attention. Bye-bye. See you next time.